So let's discuss the problem number 2201, count artifacts that can be extracted. So the problem states that we are given a grid and there are some artifacts within the grid. So for example, here there are two artifacts. So this four integers basically denotes the starting and the ending position of artifacts. So it denotes that there is an artifact starting from 0, comma 0 and ending at 0, comma 0. So this is one of the artifact. Similarly, this four integer denotes that there is an artifact starting from 0, comma 1 and ending at 1, comma 1. So this is the second artifact. Now we are digging the cells one by one. So basically this denotes that we dig the cell 0, comma 0, and similarly this denotes that we dig the cell 0, comma 1. So after digging the cell, these cells are visible. Now if the entire artifact is visible, we can extract that artifact. So in this case, we dig 0, comma 0 and 0, comma 1. So this 0, comma 0 is a complete artifact, so it will be visible. But we dig 0, comma 1, but a part of artifact 1, comma 1 is still not digged. So we can't extract this artifact. So total number of artifacts that we can extract is 1. Similarly, if we have dig these three cells 0, comma 0, 0, comma 1 and 1, comma 1, we can extract this artifact as well as this artifact. So the answer will be 2. So before solving this problem, let's try to solve a simpler version of this problem. That is, this problem is in 2 dimensions. So let's solve it with 1 dimension first. So let's say we we have given an artifact which is in 1 dimension. So this is our land, let's say, and there is an artifact starting from 1 and ending at 2. Similarly, an artifact starting from 3, ending at 6, and so on. So this is one artifact, this is another artifact, this is another artifact, and this is the last artifact. And similar to the previous question, we are digging cells one by one. So we dig 0, 3, 4, 8, 9, and so on. So basically we dig these all cells and you can see we have completely digged 1 comma 2, 1 and 2. So this artifact will be visible. We can extract it. Similarly, we have completely digged 3, 4, 5, and 6. So this complete artifact is visible. So we can extract it as well. We have digged 8 and 9, but 10 and 11 are still not digged, so we can't extract this. And we have digged 14, and this last artifact contains only 14, so we can extract that as well. So total artifact that we extracted is blue, red, and yellow. So three artifacts. Now how to solve this? You can see what you want is if there is an artifact, whether all the cells are digged or not, right? So let's say we have marked the digged cell with 1 and undigged cell with 0. So this is the same array, just we have marked y with 1 and the empty cells at 0. Now, if we take the sum of artifacts, so that we have an artifact from 1 comma 2, one like starting at 1 and ending at 2. So if we take the sum of these two cells, we will get 2. And because this artifact, which is starting at 1 and ending at 2, contains only two cells, we can completely extract this artifact. Similarly, from 3 comma 6, we can see that the sum is 4 and 3 comma 6. So the artifact extends over 4 cells. So and the sum is also 4, so we can extract this artifact as well. Now coming to the third one, we can see the sum is 2, but artifact actually expand over 4 different cells. So the sum and the number of cells the artifact extends is not equal, hence this can't be extracted, and the last one also can be similarly extracted. So there are 3 artifacts that can be extracted. Now only thing that remains is how to compute this sum effectively, right? So if we go over the entire array every time to compute the sum, it will not be efficient, because in worst case, starting from, like, L can be any from starting from 0 and R can be anywhere up to 14. So if we repeatedly go over the entire array, this approach will not work. So what we want is an efficient way of computing this sum from L to R. So let's try to solve that problem first. Basically, summing up all the integers from L to R. So this can be solved with a very well-known approach, prefix sums. So let's take an example. So first, let's say this is the array 5, 6, 8, 4, 2, and we want the sum of 3 to 7. So basically, we want 4 plus 2 6 plus 9 15 plus 11 26 plus 1 27. So the sum is 27. So what we want is basically compute every range, the sum of every range efficiently. So we will calculate something called prefix sums. Basically, at index I, we will say, okay, what is the sum up to I? So for example, at index 2, we will say, give me all the sum up to 2. So which comprise of 5 plus 6 plus 8, which is 19. Now, how to compute it is very similar, which very simple. Basically, the first one, it's basically saying that, okay, give me all the sum starting from 0 until 0, which is nothing but the same 0th element only. Now, this says, give me all the sum starting from 0 up till 1. So what is this? Nothing but all the sum up till 0, which we have already computed, plus the current value. So all the sum up till 0 is 5, plus the current value is 6, so it is 11. Similarly, when we say that, okay, give me all the sum up to 2, what we can do, give me all the sum up to 1, and then we will add 2. So we have already calculated 11, so we will just add 8. 19 will be the answer. So you can compute the entire array similarly. Once you have this array, answering this kind of query is very trivial. So let's say we want to answer this 3 comma 7. Basically, give me the sum starting from index 3 up till index 7. So to do this, we have all the sum up till 7. Basically, 46 is the sum from 0 to 7. And what we can say is subtract everything from 0 to 2. So we have everything from 0 to 7, and we are saying that, okay, subtract everything from 0 to 2. So this will give us only these 5 elements. So 46 minus 19, which is 27. So similarly, for let's say you want to compute it for 2 comma 8. So we have all the sum up till 8, which is 53. And what we will do is we want starting from 2. So we will subtract everything till 1, which is 11. So 53 minus 11 is 42. That's the answer. You can confirm 7 plus 1, 8, 19, 28, 30, 34, and 8, 42. So hope this is clear. Now, once we have solved this, solving the original problem, let's solve the 2D version of the same problem. Basically, we have 2D array, and what we are saying is starting from 1 comma 1, give me all the sum up till 3 comma 3. So starting from 1 comma 1, give me all the sum up till 3 comma 3. So this blue box is what we want. Similarly, this query is saying starting from 4 comma 3, give me all the sum up till 5 comma 3, which is nothing but this particular region. And the third query 4 comma 0 up till 5 comma 2, which is this region. So this is what we want. Now, how to compute it? We will do similar kind of approach what we have done in our previous 1D version of this question. So we will compute something called again 2D prefix sum. Basically, we are saying that any cell, let's say this cell 2 comma 2, 2 comma 2 will contain everything starting from 0 comma 0 up till here. Similarly, let's say 1 comma 4. So this 61 is basically the sum of everything from 0 comma 0 up till 4 comma 1. Basically this 5, 4, 6, 5, 11, 8, 10, and 7, and 3 and 2. So this entire sum, if you do, it will come to 61. Let's try this. 3 plus 2, 5. 5 plus 17, 22, 22, 30, 41, 46, 52, and 9, which is 61. So basically, this 61 is saying that I am the sum of everything up till me. Basically, starting from 0, 0, if you go up till here, whatever sum of the elements are is 61. So let's say we compute this array automatically. How we will compute this, we will come to that. But let's say we have this array with us. Now, again, we want to answer these questions. So let's see how to do that. Let's say we want to compute the sum of this range. Now, what we have is everything up till here. Starting from here, everything up till here. This is what we have. But we only want this shaded area sum. So what we need to do is to subtract this particular area, because we have, like, what we have calculated is everything up till here. So we will subtract this part. Now, how to subtract this part? Uh, let's see what all things we have. We have this sum as well. Basically, starting from here, everything up till here, we have this sum. Similarly, we have this sum as well. Starting from here, everything up till here. Now, if we combine these two, we will see that we get exactly what we want. But this area, this which I am hovering over, is being included twice. So this, the sum of all these numbers is included in this segment as well, and it is included in this segment as well. So we have included this twice. So we will subtract it once. So we also, we like, if you see, we already have this sum with us as well. So let's try that with an example. So to answer this all queries, so let's try to answer the first one. Basically, we want the sum from starting from here, everything up till here. So how to do that? As discussed, we have everything up till here, which is 88. Now we will subtract this part, which is 14. Then we will subtract this part, which is 32. Now, as discussed, this 5 is getting subtracted twice. So we will add 5 once. So 88 plus 5, 93. 93 minus 14, which is 77. And 77 minus 32, which is exactly what we want, 47. So you can see we can answer all this query very efficiently having this array calculated, like this 2D matrix calculated. Now let's just try one more. 4 comma 3 to 5 comma 3. Basically, we want this particular region. So what we have is everything up till here, like this entire thing, which is 123. Now we have to subtract this particular region, this entire region. So as discussed, we will first subtract this entire region, which is 88, and then we will subtract this entire region, which is 95. And because this part is getting subtracted twice, so we will add this part once, which is 70. So 123 minus 88 minus 95 and then plus 70. You can do the maths, it will come to 10 only. So now the only question that remains is how to compute this particular matrix efficiently. So let's try this. So what we'll do is similar to what we have done in the 1D version of the question. Basically, for every row, we will compute the prefix sum. So basically 5, 4, 4, 1. For this, if we compute prefix sum, it will be 5, 9, 13, 14. We are saying that this number is equals to the sum of all the numbers starting from the first column. Similarly, this number is equal to sum of all the numbers starting from the first column. So 5 plus 4 is 13 only. So we will do this for every row. Now, once we have this matrix, then we will do prefix sum column wise. So after, let's say, we have this prefix sum calculated over the rows, now we will calculate prefix sum over the column. So 5, 11, and 11 plus 11, 22. 32 is basically everything up till here. So 10 plus 11, 21, plus 6, 27, plus 5, 32. Similarly, 35 is 3 plus 10, 13, plus 11, 24, 6, 30, and 35. So first we have done row wise prefix sums, and then we have done column wise prefix sums for every columns of this row wise prefix sum. Now you can notice this is exactly what we want. Basically, this is exactly equal to this matrix 5, 9, 13, 14, 5, 9, 13, 14, and so on. So why this method works? Basically, with calculating prefix sum over the row, we are saying that okay, this number is equals to the sum of all the numbers starting from the first row. Similarly, this number is equals to the all the numbers sum starting from the first column. And similarly, for these rows as well. Now, once we have this, what we, if you remember, what we want is everything, like sum of everything from 0, 0 up till any r comma c. So if we want, let's say, r comma c is this, so we want these three and these three. So basically 5 plus 4 plus 4 plus 6 plus 5 plus 1, this is what we want. With 13 we know that okay, 13 is entire sum up till here, and with 12 we know okay, everything up till here is already calculated. So only adding 13 plus 12 will give me everything in this region. So now you can imagine why this is working. Basically, this number denotes everything before me in this row. This number denotes everything before me in this row. This number denotes everything before me in this row. So if we add these three numbers together, we will get everything in this row, in this row, and in this row up till the second column. And that's what we want. So if the explanation is not clear, you can watch the previous 1 minute of the video again. Now, once this is calculated, like we can again apply the same logic which we have done in the 1D array. Basically, number of cells should be equal to the sum. If it is not equal, we will say that we can't extract the artifact. Otherwise, we will say we can extract that artifact. So the pseudocode will look something like this. We will prepare a 2D matrix with and we will fill it with ones and zeros. So one will denote the cells which is digged, and zero will denote the cell which are not digged. Then we will prepare the 2D prefixum array. Basically, do the prefixum row wise and then do the prefixum column wise. And then for each artifact, we will count total number of cells in the artifact, and then we will and we will calculate the sum of all the cells. Once we have these two, we will see whether those are equal or not. If they are equal, we can say that okay, this artifact can be extracted, and we will increment our result. So let's quickly look at the full code. So this is a sample solution. As we have discussed, we are taking a 2D matrix filled with ones and zeros. Initially, everything is zero. Now, for each cell that we have digged, we are marking it as one, and then we will calculate the 2D prefix sum. So basically, for each row, calculate the prefix sums first, and then for each column, calculate the prefix sum. So basically, row wise and then column wise, and then we are iterating over every artifact, and then we are calculating the sum in this with the help of this prefix that we have calculated. So as discussed, the sum will be R2 C2, the ending row. We will subtract the upper portion, then we will subtract everything before this, and because we have added one part twice, we have subtracted one part twice, we will add that part. So just to recap, this is this part. So what we are doing is first taking this, basically R2 comma C2 is this one, and R1 comma C1 is this one. So this cell is R1 comma C1, this cell is R2 comma C2. What we are doing, everything up till R2 comma C2, everything up till R2 comma C2, and then subtract everything before this C1. So subtract everything before this C1, and then subtract everything before R1 up till C2. We are subtracting everything before R1 up till C2, and then because we have taken this part twice, we have to add back this part. So that's what we are doing. We are adding back this part. Once this sum is calculated, we are just checking whether sum is equals to total number of cells. So total number of cells is nothing but total number of rows which is included in the artifact, and total number of columns which is included in the artifact. If they are equal, we are incrementing the answer and just returning it. Hope this is clear. Thank you.